Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter written in Swift. We're probably through, 95% of the language per se. We probably still have some things we need to do on the interpreter or the REPL, the read eval print loop kind of side. But today we're focused on the input statement. Now we did the bulk of it last time. So if you input like X comma Y, it knows to go find two numbers and all that stuff. But we haven't dealt with the case of where you're inputting to an array cell. So if you said input B sub 3, we don't handle that yet. So let's go see what we're up against. Okay, so handle input to array cells, good. And all right, so normally we check through the lexer, the parser, and the interpreter, and I'm pretty sure we've covered the lexer because we've got the input keyword covered, and everything else is just stuff you see in any other statement. And we do this in here. This is the input. We match a variable and a comma list of variables, basically. So you can see this comma, same code here. And variable, let's see, try variable here. Let's see this thing. So it takes a name and then it looks for the left parenthesis, and if it finds it, it builds up a subscript expression. So the parsing of this is fine. It's more the interpreter that's the issue. Okay, so interpreter, okay, to input. We get the input and echo it, and if there's not enough values, we force them to try again. Okay, and then we go through, make sure that, we're making sure everybody's a variable, a simple variable. So the other choice was array access, and we don't handle that yet. Okay, so we'll need a test. Okay, input with one string, two strings. Okay, let's do a variable. Input with, how about input to an array cell? I guess that's with input. And our input, we can just do a number. And, oh, that was the program. Here's the number, 42. Our program is 10 input B sub 3. And it should create the B array because it doesn't already exist. Input that, okay, and then what does it expect? Well, I guess we should probably print it. We'll print both, B sub 3 and B sub 4. Okay. And so the first one we want to see 42, space 42. I'm going to do semicolon, maybe just nothing between them. I think it'll work like this, space, and then a space, 0 space, new line. I might have the spacing a little wrong, but we'll have bigger problems first. Okay, so it assumes there's an array B of one dimension, and it should dimension that to size, well, to maximum index 10, which is 11 entries. And then we're printing out the one that's there, and then this should have been set to 0 by default. Okay, and we expect an error from that throw conditional we just looked at. Can't happen, only single variables so far. Okay, that's where we expect it to be. All right, so let's do this. switch expression, and we'll do case variable, let name, let type, do something case array access, name, type, and expressions. They're really subscripts. And then anything else is an error. Kind of a can't happen. And it should be a can't happen because the parser would have caught if you tried to, you said like input 42. Well, it's got to be a variable and it knows that. Okay, so it's a can't happen. This really is location.line number. And okay, so now we don't need this. And this stuff is all the case for guess that's to here. That's our variable case. I don't know if I left out a brace. Good. Good. Okay. And then, well, let's keep it minimal here. Okay. It's not exactly the same message, but I'm just trying to get the shape correct first. Okay, so when we come in here, we check some stuff, and then we're going to go through each item they're trying to input and handle the case, either variable or array access. Okay, so let's run this test again. Similar error we expect. That was more of a refactoring. Okay, and then let's extract method on this one. Oops. Okay, this is input for variable. All right. Yeah, let's. Well, I think I'll manually do this one. Oops. I like these. Oh, how weird. Can't find fields. Well, you're the one that was supposed to analyze my code and figure out what was going on here. Okay, fields is string.subsequence. Okay, so we'll pass fields here. String.sub, oh, capital S. Okay. Mutable variable subscripts was never used. Well, that, oh, it's just got confused about where the errors are. Okay. Once more. Okay. And now I'm going to assume a new method into place. Input for array access. Access fields index name type subscripts. This is really type. Okay, and again, same failure. Whoops, what's going on here? Errors not handled. Oh, this should be throws. Fields index name type subscripts. Fields index name type and subscripts. Okay. Okay, test field is progress. All right. And one more bit of funniness. I don't know why it didn't put things in the same order I wanted them, but I want to swap these two. Well, name and type. Okay. And again, same error. All right. So all this is just kind of nudging it to a parallel structure so I can do this stuff down here. Okay. Now this, I think we want to do more like doAssign. L value expression. Yeah, I think we can lean on doAssign very heavily. So I guess this type, we're going to switch on that. Okay. Okay, this is going to be similar. I'm going to comment this stuff out. Well, I'm going to is it skip? Can't remember if we have that. Maybe not. I don't want to handle string yet. Okay. Yeah, really, I want to make an expression. I want to make this handle with doAssign. Okay, now this bit, that's the same. Maybe I should be switching on the type first. Okay, but this, because this requires evaluating all the subscript expressions, oh no, it's not really the same, is it? Maybe I should just be passing expression. Let's try that instead of peeling apart this stuff. I guess we need fields and index still, but this stuff we'll just pass expression. Is that going to help? We know it's an array access. Maybe I should build it up again. Okay, that's getting the number. If I said doAssign array access of name type subscripts with, we need the expression form here of a number. Okay, well, that's pretty easy. It's just number value. Okay. That covers that. Right. Okay, is that a syntax error? Interpreter error. Oops. Dot. Can't happen. Okay. And now I think this should pass. Well, whoops. Space 420. Oh, right. The input does appear in the, we echo the input. That's part of it. New line. Okay, good. And then, I mean, there's still duplication and stuff. I'm not happy, but let's get the last case working and then we can try and find a way to cycle this thing better. Excuse me. All right. So I want another test case to a numeric array cell, and we'll do something similar for string. And notice I'm not worried about like multiple dimensions and stuff because the runtime system already takes care of that for variables and subscripts and all that stuff. So there's no reason to add the complexity in. And I don't think I need to echo this one. Yeah. Okay. Just to make it a touch more readable. Okay, input to string. This should blow up. That exception complaining we don't do it yet. Yep. Okay. And then I think we can do the same thing. We'll try doAssign. Array access. Name type subscripts. With dot string of field. Okay. Good. All right. Let's push this. So handle subscripts in input. Input. All right. And now let's do assign do. Oh, it worries about that too. So, all right. So the real thing is the type is the real thing the type is controlling is what kind of value gets created, or expression actually, because we're just feeding it through as an expression. Okay, so let's do that. Let's echo this. Okay, and yeah, I think this stays the same. I don't know if I can do this. I just want to declare it here and then fill it in one of these paths. Okay, so that's this. It equals that, or we'll do this stuff. Dot number of float value. Okay. Okay, I guess I'm allowed to. So I'm making sure it's filled in on either path. Well, each path must fill it in or throw an error, and we've done that. Okay, so now we want to use our value. Let's use it here. And here. And this should pass. Okay, we don't need float value anymore. Okay, Now I got these two things. They're passing identical stuff to identical stuff or an error type, but the error is already covered down here. I don't know, that's a little jargony. Can only assign to either. Okay. That may be checking that message somewhere, but that's fine. But this is being done in both cases or an error. And I'm zooming out, and this is, I don't know, it's a little bit, I'm basically abstracting my behavior that I either do something or throw an error, but I don't care which error as long as something reports an error. And in sort of that projection, in sort of the mathematical sense, right, I'm abstracting that out. That should behave the same way, assign something or throw an error. But I'm not worried about which error. So it's I don't know. It's a borderline refactoring. I mean, there's definitely places for it. Okay, but okay. So here, I guess I can just do this now. Since both sides are doing the exact same code, I don't need to switch on the type anymore and all that stuff. Okay, and this should pass. All right, so let's commit that. Make input handling for, I'll call it ish just to make it, I don't know. I suppose I could dig up Arlo's notation and use that, but I don't get enough benefit out of it usually. We're simplify input handling for array access. Okay, and so now I'm kind of reversing all these decisions, but name type and subscripts, the only reason I'm passing that in is because I use it down here to rebuild it as an array access. Well, I already had it as an array access up here. I don't need all that. So let me just not pass it. And I'm going to pass the expression instead, which is expr. Okay, and now the third argument, let's see, input for array access. This becomes expr of expression. Ah. Oh, we're lost it there. Okay. Expr expression, and then here, this is that expression. Okay, and switch type. Oh, yeah. Well, I want to push this up too, but for now, I will just take it. And pass it in up here. Let name, let type. Okay. And that should pass. Okay, now notice this code. Here's string. It computes value.string, or it computes the number and then stores it. Well, we did similar code here, right? We computed this R value. So let's take the same approach. We're going to drive this stuff to be completely duplicated so we can get rid of it. Okay, and then we switch type. Case string, case number, default. Okay, so string, we want this. This one is our value equals, well, we want this stuff. Okay, and now, right, we got the R value. I believe I can just do doAssign. Well, no, let's see. What's a smaller step, right? Okay, I got R value here. Yeah, let's move this over to doAssign. Okay, so doAssign was actually just after this. Okay, it needs an L value that's either a variable or an array access. Okay, so input for variable. Okay, this is doAssign variable name and type to R, gets R value. That should be the equivalent to this global subname thing. We don't need this anymore. And again, this is going to be a doAssign. Variable name type is an R value. Okay, that. Oh. Okay. Now, variable name type, well, where's that come from? Well, that's this case up here. We had variable name and type. Okay, let's just modify this one to be expert again. And we're still looking at type. So let's take this out and do expression. And then here we'll keep the type, lose the name, and pass expression. Okay, now instead of building up a variable name type, we know that's the same as expression because we just passed it in. Okay, and then the caller, yeah, we don't need to look at the name here anymore, but we still need the type. Okay, let's. Good. All right, now oh, okay. It's going to get simpler. It's okay. This computation of the R value is the same in both cases. So R value equals string, or dig up the numbers. This is down here, same deal. Okay, so this is happening in front of each of these two cases. Here and here, it's the first step of each of these, so we can pull it up. Okay, so let's pull the field and this. I'm just going to do a copy for the moment. Okay, and type. Oh, we pass that in down here. Can I get the type? Let me go look at expression. I think actually it's over. No. Parse. Expression. We can find the type. Okay, so if it's numeric or string, so we can ask the expression for the type. Expert. Let's go for expert dot type, and I think that was a method, right? Okay, so now we've computed this. It doesn't modify anything; it just computes it. So there's no harm in doing it twice. Okay, should be no difference. But now, instead of passing fields and index, the only place index is used is here. The only place field is used is here. Sorry, index is used here. Fields is used here, but not anywhere south of that. So if we were to pass in that L value instead of fields, I guess we would still need the expression, but we just need the R value. Okay, so we don't need this stuff. We do need the R value is of type expression. Okay, so input for variable just needs the expr and the R value. Okay, input for variable needs the expr and the R value. Now we're not using type anymore. Let's take that out. All right, and this should be the same. Okay. Cannot find fields. Input for variable. Oh yeah, I got to take out all this stuff. Okay. And this, we can switch expert.type again. Well, actually, R value.type is probably more interesting. Okay. All right. Okay, and then, well, here we can do the same thing we did down here, right? These basically boil down to that. To do assign, since each case we do an assign, then let's just say do assign. And again, we trust it throws an exception in the one case, but we don't care if it's exactly this expression. It's still good enough. Okay, so we don't need the R value type anymore. We're just doing do assign. Okay, and that should be good. All right, now let's inline this. Input for variable is that. Okay. nobody should be calling this. It's private. So I think, what you can see is I'd have been better off if I'd pulled this common code out first and then extracted, but it just was too much for me to look at. But it would have been a better way to switch early on type and then compute the rest of it. But that's okay. We're getting it now. All right. So now I'm going to change this name to L value because the expression on the left is the place we're assigning to. So it I don't know if you were there or run across it before, but L value is left value and R value is R value. And it's a notion computer compiler writers use to talk about the left side of an assignment and the right side of an assignment. They have similar forms, but if you're assigning into something, you access it differently than if you're assigning from it. Okay. All right. And okay, so we're computing that value. And then we got this doAssign. Let's go down to our array access and make that better too. Okay, so now input for array access. Well, all this stuff, that's really the same as the R value we could pass in. So we don't need the fields index or type. We just need the R value. Okay, and if we had that, it boils down to this. Oh, didn't fix my call site, sorry. L value and R value. Okay, good. And now let's inline this. Input for array access, good. And that goes away. And expert is really L value because I renamed it. Okay, and now I've got that same pattern again. I've got variable array access. Two cases, either one does the same thing, or it blows up. But doAssign also looks at, are you a variable or an array access, or you're some sort of other thing, and I just throw an error. Okay, so we don't need to throw here, and in the third case, we can just do this. All right, and this goes away. Immutable value type was never used. I think that's gone too. Okay. This is still more than I want, but it's improving. Okay. Now this, all right. Well, let's check this in. This is a good position. Okay, so it's refactoring. I say harmonize, variable and array access. So everybody's doing the same thing now. And really the thing that's going on different here, it's this computation of the R value. that's the thing that has to know the type, right? So, because you're saying input, you could be inputting a string or a number, and it's got to interpret the text. Well, there's not much interpretation if it's a string, but it's it's got to turn it into a float if it's intended to be a number, and so on. This thing is the computation that is kind of the input processing, basically. Okay, so let's extract that. Well, what we call it? We'd convert input to expression. I think might be right. All right, and let's pull this into a variable. I'll just say the field for now. I'm just going to get this thing. Okay, and extract method. What's the problem? Well, he needs L value. He needs the field. Well, let's copy it. Okay, so this is convert. Function convert input to expression. It needs some stuff. It throws and it returns an expression. Okay. What do we want? Well, we'll have input of type string dot subsequence. No, maybe this is, that's the caller's job, I think. Let's leave this line up there. Input string. Right. And I guess this wasn't a good move. Okay. Now we have this bit. It needs the type from the L value. Right. I think it needs a type. And type of type. Okay, and this is type. I renamed it. And then I'm going to return our value. I can throw. Okay. So now we can call this. This for input, which is field, and type, which is lValue.type. Okay. And that replaces all this. And I'm going to inline this. Okay, oops, sorry. Let's see. So now we run through the expressions. We convert the input to an expression, and then we assign it to the L value. Okay, I like it. Excuse me. Okay, so this was more refactoring. Excuse me. Let's see. So I think we've done what we set out to do so far. Where's our to-do? Okay, handle input to array cells. Yeah. So this is July 4th. All under input. Nope. This one, I had the notion that there's an input area and it only shows up. We could make it so it only shows up when it's actually waiting for input, but I think it's going to have the effect of kind of popping in and out, and I think that'll be too annoying. All right, so this one we did. This one I'm not going to bother with. And if there's too much input, well, there's each of these three basics has different ways of handling it. Well, actually, this first one, the original basic, they didn't have an input statement for next, no input. Okay. You just did this read and data stuff. Let's see, where do we find it? Yeah, so here's read and data. You can assign variables by reading from these data statements. Okay, there was no true interaction. Like what? Yeah, so that was an innovation in the. Well, they may have added it too. I don't know, but it was certainly had evolved to have an input statement by the time of this 8K Basic, which was mid 70s ish, I think 76 maybe, and certainly by the time Commodore 64 came along, like I don't know what 82 somewhere in there. All right, and let's find the input statement here because I think that we don't have to do everything it does, but I think it's a reasonable model. So basically, I mean, they provided a fair bit of stuff, but one thing they did was if you got too much, it put it out a message extra ignored. Okay, so I think that might be worth doing. It would help the user in the sense that they recognize like, oh, they typed more input fields than you needed. Okay, so I think that's our next activity. So if there's too much input, print extra input ignored. Okay, so that's what happens. All right. And I think for us, we've been going about an hour. So let's take a break, just like 3 minutes, and we'll come back and do this. And I think that will wrap up the input statement for us. Rather than going on, I think I want to consolidate and do some refactoring on my tests and stuff. But I think that'll be a nice little touch there. So 3 minutes. See you then. All right, welcome back. So okay, if there's too much input, print input, extra input ignored. All right. Interpreter tests, and we had I would have thought we had a test for that. Input with wrong number of values. Okay. This is really with too few values throws. Too few values. Okay. And I'm going to move these. Well, let's move this one down. Okay, and then let's, and ignores them. And it might throw, oops. Okay, we might be able to get by with this one. I think this will be fine. Okay, so if we say input XY, but our input, we input too many numbers. Well, maybe we put in some words, extra words, and a number. Okay. We expect it to echo still. 4 extra words, 99. And then we expect another message. Extra input ignored. New line. And then we're printing them 3, 4. Yeah, that part seems okay. Yeah. Okay, so we got 3, 4 extra words, 99. That part's the same. But we didn't get this error message printed. Okay. All right. So here, we check if field count is less than count, we print an error, or we throw an error, and we force them to try again. But this case is really else if fields.count is greater than expers.count, then we're just going to print the extra message. We've already echoed them in line 534, so we're going to do another print. Exper string extra values ignored. Is that the message we said? Extra input ignored. Okay, and then string expert print and parameter number 2, with a new line. Well, that looks pretty similar to me. Extra input ignored. 3.04 comma extra words 99. Huh. That looks the same. Well, let's we'll pause right here and see what we can find. So space 3.0. Oh, a space after the before the comma. Three point oh. Yeah, got rid of that space. Okay. Yeah, it's there. Okay. Okay, we'll run all tests. All right. Make input report an error if too many input values are typed in. Good. All right. I'm going to split out interpreter tests by statement. All right. So this I want to up the quality of reading these tests. I feel like there's just too many. I don't know what we have for lines, but it's hundreds. Okay, almost 1,200. And I think the behaviors we're checking really are tied to each statement type. Okay, I mean this is so minimal; it's kind of a pity. But let's my strategy. I think I don't want to make these static methods. I think I can leave them up in this class and make a subclass. So let's break this. Let's put a group in here. New file. Oh, I guess there's a new group. New group. Okay, and this will be interpreter, and it's only contents right now is interpreter tests. Okay, and let's move it down. Okay. And these moving and changing, I'm more and more tending to split them up. Okay. Move interpreter tests to its own group. And that is a refactor. All right, and then let's steal this. Now my hope and expectation is that it just runs them. So I'm going to take the easiest one, which was that remark statement. I think I've got enough information. I don't need to do that. Okay, so how about remark tests? All right, and import that. I'm going to say remark tests extends interpreter tests. And I'm going to pull one in. Oops, where'd interpreter tests go? Okay. And this is probably the only one. So we'll take an easy test case. Now, I'm assuming we will run all the tests and remark tests, may run all the tests. So until we're done, we're going to be redundant. Right. So I guess we don't have any active. Okay. But let's make these public first. Well, I don't think I have to make them public, right? If they're just in the same package. It's no harm like this. So my expectation is we run test remark, and then it's still going to run all these functions that are tests valid for its parent class. And then it's going to come in and run the parent class and run all those tests again, I believe. We'll run all tests. 261 is where we were. I don't think it's going to be 261 this time. I think it's going to be a lot more. Yeah. Okay. So I guess there's 105 tests in here or something like that. But that's okay. Remark tests. Now let's do print tests. I think I can improve this name. Test print adds new line. Test print numeric value. I'll move this one up. Even though we implemented this a fair bit later, I think print adds new line maybe by default. Print with semicolon suppresses new line. Print numeric, print multiple, print commas, print tab. Okay. Now I think there may be more print related ones too. Oh, remark? That's actually part of remark. Now this looks like a repeat, right? That's the same as that first test. Down to the, well, not quite the line number, but okay. Print with numeric value. How about print integer value drops decimal point. Okay. Now these use print statements, but they're more arithmetic. This one is not. Well, the name is wrong, right? It's more evaluate. Well, this is more just addition. The print is not. It's a way we're observing, but we're not testing the printing facility. Go to if statements. This was really more of a spike. Notice it's not doing anything with our values. It's just looking at dictionaries and how they work. Oh, that reminds me. I think we have some, part of the issue here was reset global dictionary. Should it be layered? Okay. So we have some ability to layer the dictionary in the sense that if a new value in function, there's a one-line function call that creates its own variable, and then it basically if you reference that variable, it gets used, but the existing variable of that name is still around. So it's kind of like a nesting scope kind of thing. But yeah, that's a future fix. Okay. Let's continue looking for prints. Oops. Interpreter tests. Yeah, def. Good. There's some inputs we've been doing. Print integer uses no decimals. Okay. An integer uses no decimal points. A float does use decimals. But I think maybe this is relevant to that. Okay, I think that's probably still relevant test-wise. Random numbers. For loop. Go sub on go to. Okay. I think that's everything for print. Run all tests. Now that number of tests is not going to shrink back until we get every test out of the parent class. And really, I'd like it to be an abstract class, but Swift doesn't really quite have that notion. Okay. Good enough. All right, so we've split out rem and print tests. And we'll just alphabetize there. Okay. And I think I'm going to rename this. I'm going to put it. I kind of want to mark it like that. It's a little odd not to name it the same as the class name, but I think it's communicating something real. Okay. Well, here we're at input. Let's just grab that one while we're here. Input with one string variable. All right, I have a little other header stuff I need. Maybe this is dim and array. See if it'll rename the file for me. No. Oh, it did. Okay, cool. This one, that's That's actually testing something different. I think I'll leave that out. These check that. Yeah. This is 4. And next. Tests. Goes up, yeah. I should say go sub return. On go to. Now the stop statement is kind of a breakpoint, and we provide a facility to let you resume it. And I know we tested that somewhere. Let's find the word resume. Oh. That one really is part of the input. Okay, that's a different thing. I don't know that resume is the best word, but I guess the real tests for that are probably over on the REPL side, not this. Okay. Excuse me. All right, let's pull out all these expression ones, but I think we'll pull the system functions out to its own thing. And I'm going to make this one, again, since it's not a basic construct, I'm kind of giving it the underscore name. All right. We're getting to the end. Okay. Go to well, okay, let's do end. Maybe stop and end can be in the same file. I'm going to call this go to control flow. No, you know what? It's just going to be control flow. Control flow tests. I think even that might be a legitimate part of this one. Step go to multiple lines. Okay, but not if. We had more than that. Okay, here we go. Run them all. Okay, let's check these in. Okay, this one's deaf. That's probably a good one. I'm going to call these part of expressions. And I think, yeah, we're left with one. So I think, was it 261 originally? Do I have a dozen running this? Okay, let's pull this one. File. Okay. Let's run them all. What's the matter with that one? Oh, hey, nice to see you again. I hope I didn't miss your message too long. We've basically just been doing some cleanup. We finished the input statement handling input to like subscripted variables, and I just wanted to go in and clean up this interpreter test. We had 1,200 lines of tests, and so I've split it up into about a dozen files. I'm not quite sure what's going on with the check-in, but hopefully this works. I'll just extract tests again. And make sure this got checked in good. Okay. And run it one more time. Okay. So I think I've cleaned this up quite a bit. I'm hoping, because we're not in the mode of adding new statements all the time. I think the next one that comes in will just be another file, and we'll just add one for the read statements or data statements or whatever. Okay. Interpreter itself is still good sized. Let's see, I'm up to 500 and I'm not at the bottom. Yeah, we might be looking for more in there. I think I can turn off all breakpoints somewhere. Delete all breakpoints. Okay. Yeah, I feel like there's still more going on there, but that's okay. All right. Let's mark our to-do. Split an interpreter test by statement. This is more of a refactoring. Okay. Data read and restore. Yeah. All right. Let's start these. I think I can kind of show them off here. So basically, the data statement, you can put them anywhere. People often put them at the bottom, but it can be anywhere. And it just defines values, 1, 3, 7. The later basics let you have strings. Strings may be read in data statements. Even the old ones had it. Okay. And then there's a read statement here. And you just give two variables, well, any number of variables, simple variables, strings, array variables. And it goes back and it starts at the first data statement. When you say read VW, it reads the next two numbers. And if you come back around in your loop and you hit line 490 again, it's going to read the next two numbers and the next two and the next two. And eventually, if you run out of numbers and you call a read statement, it's like a stop to your program. It's an end statement in effect. So it lets you read these values until they run out. With any of these, we start with the lexer. And I don't see it here, so let's just take a look. We want to know if the read statement, okay, there's read and data and restore. Okay, restore just resets all your data statements back to the beginning. So those exist. The statements themselves, they're just constants, right? So you had string, well, these ones had numbers, 1, 3, 7, constant separated by commas, and potentially string values. I don't know if those have to be quoted. That's interesting. There might be more going on here. for data, list of constants. Oh yeah, oh boy, good old basic. Okay, so in this circumstance, you're allowed to have string names. It knows it's a string, John, Paul, George, and Ringo, or 4 strings. Wow, that's going to definitely complicate our lexer because we normally have constants like this in quotes or numeric, but if it's a data statement, you can have unquoted strings separated by commas. Oh my goodness. Okay, so that is going to complicate things. And the way we've dealt with it before, like there's a couple situations where we've had temporary, we've had a little bit of state being tracked. Hey Rick, thanks. I live in Omaha, Nebraska, and apparently fireworks are a big deal here because there's tents and stuff everywhere. And I don't know how much we'll see tonight, but there were a lot going on last night. Okay, so well, we did have something. I think we kind of cleaned it up. We had something when you did line numbers to know that you were looking for an integer for the line number. And let's see if we can find line numbers. I saw something if line number equals nil, line number equals int value. Yeah, so we're storing that potentially. We had a messier approach, but I think the same thing's going to apply. That we're going to have to be saying, I saw we're in a data statement. So I'm going to allow strings. What does it allow? I mean, I guess I suspect it would trim spaces, so it would look and find John with no space in front, Paul with no space in front, and so on. So let's see. We had the remark statement is kind of interesting like that. Let's find remark. Oh yeah, here we go. If keyword is remark, ignore until end of line. Okay. I'm kind of not wanting to get into this just yet. Okay. Let's deal with that by punting it. Okay, so at some point, I kind of stack these. So simple data statement with numbers or quoted strings. And then we want to allow data statements can allow strings without quotes. Can allow comma separated strings without quotes. And then we have read. I guess it's number, string, or array value. And then restore. Okay. So I think we will start with the parser. Maybe we can get a little bit done in the last few minutes here. And we'll just handle, let's start with numeric. quoted strings, and then I think, I guess I should split these up more. Read a number. Okay. So I'm gonna get these two working together first with just numbers, and then grow them to handle strings, and then fancier quoted unquoted strings. Okay, so parser tests. And these have gotten kind of unruly too. Come up and print. Okay, well, this is data. Test data with. No, I guess we don't have to. We're just checking the parse with only numeric values. Okay, and this is the kind of thing we want. Okay, so if we have 10, data 3, 2, 1, we're going to expect, well, it doesn't exist yet, I don't think, but what should these be? Well, parse has I almost think they should be values. Let's make them values. Number 3, number 2, number 1. Okay. And the data statement doesn't exist in parse. Expression dim. I guess data. And I'm saying it's going to be value. Let's see if that works, because it may be, I'm not sure where value gets defined. I don't know if we did it in the lexer. No, it's an interpreter. So maybe this should be expressions. Where to go? Parse data. Let's make this expression. I think we're okay because they both use data. All right, now the interpreter will complain it doesn't know how to interpret data statements. Yep. Okay, so switch, sign, case data. Ignore the contents because we're just going to throw a message. Error can't happen. And the message is don't handle data yet. This should fail. Okay, unknown statement. We don't know how to handle data statements yet, and we were expecting this. Okay, I think we are going to stop here. We'll have a red test to tell us what to start with next time, and we know we need to parse it. Maybe we can squeak in the case statement for it. Up top somewhere. Okay, case data. Okay. Oh, I didn't say do in there. Okay, let's just call it function data. throws yields a statement, and we're going to return dot skip for now. Data, try data. Okay. Same test should fail. Just a slightly tighter message. Okay. Extra characters at end of statement because we saw a data statement, but we didn't tell it to parse any of these numbers. Okay. Right. Okay. That'll give us a place for tomorrow. So tomorrow it's 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. Oh, yeah, 3 to 5:30 p.m. UTC. Thanks for joining. And so again, what we did today, we got the input statement working for array cell values, and we cleaned up the interpreter tests so that they're organized much more by statement type, or at least kind of general type. So we know when we want to add a statement or modify one, kind of where do we go. I think that'll be a little more clear there. The interpreter itself is still pretty big. I don't know if that's a problem or not. We'll have to judge that later. And I think we're good there. So thanks for joining and take care. Have a good evening. Bye-bye.